For our group capstone project, we focused on X-ray image prediction of COVID-19. So good classification of X-ray image datasets can help with early diagnosis and play a crucial role to slowing down this COVID-19 pandemic. So the solution we came up with was a computer vision application that screens for COVID-19 based on patients' X-ray images. This image classifier is built on X-ray images from patients with COVID-19, pneumonia, or considered normal. So the user interface of our application allows patients to upload X-ray images, and the application then analyzes the images and provides the classification, that being COVID-19, pneumonia, or considered normal, and the associated probability of having that classification. So we created two models in aim of being able to compare the results. The first approach was using AutoML within GCP. The second was creating more of a traditional convolutional neural network using Keras. As COVID-19 is a respiratory disease, it can cause a range of breathing problems. Signs of this respiratory inflammation can be seen on chest x-rays, as we see in the images on this slide. Additionally, it's important to note that there is limited training data due to the limited public medical images for chest x-rays. This is because medical image labeling can only be done by doctors or trained professionals. So this adds an additional layer of complication to the amount of data images for our training we were able to get. So a bit of information about the data. These images, again, are frontal chest x-rays. They're sourced from around the world, and we have a total of 1,293 images, and you can see the breakdown here.
So for the AutoML system architecture, first, the X-ray images that are used to build the classifier are uploaded to cloud storage, and a model is trained. Application code and updates are then containerized, and the images are pushed to Google's container registry using a CI/CD pipeline. Through the pipeline, the container image is deployed to Cloud Run automatically. For our application, the API is set up using Flask. Through the API, an image payload can be sent to AutoML for prediction and will also be uploaded to cloud storage. Classification or score are returned as a JSON response. Request data is collected and stored in BigQuery. Timestamp of requests, file names, and storage location is also stored. Users or clients can access the front end and API through a public URL. API requests require a JSON web token. The system architecture that is built around the Keras model is essentially the same. The only difference is that a prediction that is made does not use an API to an external service. A prediction that is made on an image payload is based on a saved model that is loaded every time a request is made. It is important to note that the model requires a lot of processing power, which cannot be supported by Cloud Run. A future implementation can deploy the application to a GPU-enabled virtual machine or Kubernetes cluster. Continuous integration and deployment are set up using CircleCI. First, the application API and front end are tested using GET request, and the API is also tested with the prediction post request. Tests are made using PyTest and Python. Next, in the workflow, the application code is built and containerized using Docker and pushed to the container registry. After the images are successfully pushed, the application is deployed. A load test is then run to ensure application functionality.
Our solution uses Google Stackdriver service for monitoring, logging, diagnostics to ensure optimal performance and availability. The service gathers metrics such as usage statistics, network latency, requests, and compute time, and are visualized through custom dashboards. Health checks are also set up with alert policies that will send an email or a message on Slack to notify that a service has gone down. Error logs are also sent to Slack in a centralized fashion, and users are notified by email as well. And here is an example for alerts that are notified on Slack channel.
So let's take a closer look at our first model. Again, we used AutoML vision classification and GCP. We trained the model from the labeled images and evaluated the performance. So looking at the quality and accuracy of this model, we have a precision score of 86.61%, which represents the fraction of the classification predictions produced by the model that were correct. Additionally, our recall score was 85.27%, which represents the fraction of rows with this label that the model correctly predicted. Finally, taking a look at the confusion matrix, which also has pretty good accuracy. Again, it helps to understand where any misclassifications may have occurred.
For our second model, we wanted to compare the results of the AutoML model with that of a traditional CNN. We decided to build this homegrown model utilizing Keras and TensorFlow. In this model, we were able to achieve a training accuracy of 75%, validation accuracy of roughly 78%, and a test accuracy of 71%. Although we were not able to get the accuracy as high as that of the AutoML, our results are still much more accurate than a random guess. So in conclusion, our image classifiers have broad applications across many industries, including that of the healthcare field. Models can be quickly trained and applications can be rapidly developed and deployed. We were able to achieve a good performance with AutoML out of the box. But in terms of healthcare practitioners, they can best be used, these models, to predict for patient screening and prioritization, and machine learning systems in healthcare probably are best suited for supportive functions.
So to demonstrate the front end of our application, here I'm on the AutoML version of the application, and here I'm on the Keras version of the application. On both pages, you can see the API docs link, which takes you to Swagger, which you can see the documentation for the API. Also, there's a link to learn more related to COVID-19. This is a CDC website that gives basic statistics on the COVID virus. Here's the form data. This is what a user inputs and gets uploaded to BigQuery, and also symptom data. And this gets associated to the predictions for further analysis. Now what I'll do is I'll demonstrate uploading an image. In this case, this would be a positive COVID case. Submit. And there you can see the results, approximately 100% that is COVID-19. Using the Keras model, I'll do the same. The same image. And here again is the results. So that concludes our presentation. Thank you for your time.